Hello and welcome. I'm Brian Mahalik from Solar Energy International. Thanks for joining me in this presentation on National Electrical Code considerations as they apply to PV systems. We'll be talking about the purpose of the National Electrical Code, the NEC. We'll certainly dive into some terminology that we'll be using. We will look at proper procedures for installation of equipment and conductors, minimum requirements for working space around electrical equipment. We'll take a look at expansion fittings and when they're required, and we'll finish up talking about methods for PV array wire management. So, the basis of this course. We're talking about design and installation of solar electric, photovoltaic, PV systems, or whatever you want to call them. But we're going to be relying very heavily on the 2020 National Electrical Code. Now, the document itself is not required to take the course successfully. We'll be giving you the information you need, but getting familiar with it and going to the source and reading the actual source language is really valuable. The more time you spend doing that, the more familiar you'll become with the layout of the code, the more easily you'll be able to find things in there, the more easily you'll be able to make a case for something that you want to do that you believe is code compliant, but other people may think is not. So that source material is important, but you don't have to have it to take this course. Now, if you want to, you can check it out for free. The current edition, as well as previous editions, can be accessed online for free. There's the URL on the screen. You can check that out if you want. And of course, if you go to nfpa.org, you can also buy hard copies as well as enhanced online access to the 2020 National Electrical Code as well as earlier editions. So what is the purpose of the National Electrical Code? This is laid out in sections 90.1A and B. Where does this come from? This comes from the National Fire Protection Association. That's the organization that publishes the National Electrical Code. They publish a bunch of other codes and standards as well. Now, fundamentally, keeping that in mind, we want to realize that the purpose of the NEC is to protect people and property from electrical hazards. It's not to help you design awesome systems and install them fast and make a better profit margin on them. Right? It's not a design manual. It's not something you can read as an untrained person and learn all about solar electric or, for that matter, any other kind of electrical system. Right? So it's very important to keep that in mind. It's also important to realize that the National Electrical Code prescribes minimum standards. Minimum standards. The bare minimum. Now, these standards are enforced by what we call the authority having jurisdiction, the AHJ. Your electrical inspector, the building department. In different areas, the AHJ may be different organizations. You may call them different things. But in general, what happens is states or smaller jurisdictions adopt a national electrical code, and then the building departments enforce it, both in terms of issuing permits, performing inspections when systems are installed, and that's how the two work together. It's important to realize that, and this is a quote, this is right out of the code. If you follow these provisions, you're going to have an electrical installation that is essentially free from hazard, but not necessarily efficient, convenient, or adequate for good service or future use. Okay, hang on. What are you telling me here? Well, that kind of wraps back into what I was saying. The purpose here, safeguard persons and property from electrical hazards. Your PV system, it doesn't actually even have to work. You could install a code-compliant PV system that never turned on. Right now, okay, maybe there's some violation in there that prevented it from turning on, but that's not the point. The point is safety here, and it's not to teach you how to do things. It's to give you rules that you need to follow so that the installations you perform are, in fact, safe. What about changes to the NEC? You heard me earlier mention, the earlier editions online, access for free. Well, this is a public process. There's a clearly defined process that the NFPA goes through to update the National Electrical Code, and the fundamental basis of that is public input. It is a public process. You or your company or some trade organization you work with can write up a proposal, submit it, and it will be considered by the code-making panels. There are a bunch of them, and they have different articles that they cover in different areas of the code, and that process is ongoing kind of all the time. We're focusing on the 2020 National Electrical Code. As of this recording, 2023 is already in progress. It'll probably be that 2023 will come out and some places may not even have adopted the 2020 National Electrical Code yet. You have to realize different jurisdictions are on different cycles. You got to do your homework and make sure you're following the cycle that the AHJ is going to enforce. Okay, so get involved. It's a public process, right? There are public inputs that are submitted every year just from some person that had an idea or didn't think something was clear and wanted it to be changed or updated or addressed better. That stuff is considered, and sometimes it makes its way in and sometimes it doesn't. It all depends on the technical justification and merits of it. A good way to add some weight to your public input is to get involved with a larger industry group where various stakeholders can come together, craft proposals that are going to appeal to a broad group of stakeholders, submit them as a group, and that has more weight rather than just coming from a single individual. So lots of ways to get involved here. If you want more information, again, go to nfpa.org, search for next edition, and it'll have the timeline of what's going on for that next edition, the meetings that have already happened, drafts if they're out, all of those sort of things if you're interested. So always be thinking about that next cycle because 2023 is coming fast. Here's the schedule. The first draft, well, already due. You already had to have your public input in by September of 2020. That's right. The year the 2020 code comes out, you've got to have any inputs you want to make done by September of that year. July 2nd, 2021, we'll have the first draft come out. Again, public comments on that draft, and a second draft will come out in March of 2022 with the goal of a published version of the 2023 National Electrical Code in September of 2022. And here at SEI, we'll start the process all over again, updating, changing curriculum, making sure that we're on top of whatever changes there may be, because a lot of changes are happening fast, more so in our industry and energy storage than other parts of the electrical industry for the most part, because our industry is growing rapidly and there's all kinds of new stuff happening all the time. I think if you spend any time in the industry, you know that already. So let's take a look at the arrangement of the National Electrical Code here. It's important to understand the different chapters, the different articles that are within them, and how to get around in there and which ones take precedence, because sometimes we'll have differences between articles and what they say you have to do. And we want to know, well, which one pertains to what I'm doing in particular. So chapters 1 through 4 apply to all electrical installations. All electrical installations. So chapter 1, general. There's a bunch of definitions in there and some other general requirements. We'll talk about some of those when we get to workspace clearances. Wiring and protection, chapter 2. This covers a range of things from branch circuits to services to overcurrent protection to grounding. Stuff that's going to be part of nearly all electrical systems. Chapter 3, wiring methods and materials, would be going there when we size conductors or when we look for requirements for specific types of cables or raceways or other wiring systems. And then chapter 4 is equipment for general use. Lots of stuff in there, from generators and batteries to panel boards and all kinds of other equipment that make up electrical systems. So we'll be spending a little bit of time in there as well. But what we'll really focus a lot of our time is in chapter 6 and chapter 7. So chapter 6, special equipment, articles 690 and 691, photovoltaic systems and large-scale PV. We'll be spending a lot of time there, as you can imagine. Chapter 7, special conditions, articles 705, 706, 710, 712 are of particular interest. 705, interconnection, yeah, we're going to spend a lot of time on that. Energy storage, standalone systems, DC microgrids, not so much in this class, but in other PV applications, yeah, those may be very pertinent to what you're doing. It's important to understand, and this is stated in section 90.3 of the NEC near the front of the book, that chapters 6 and 7 may supplement or modify the requirements in other chapters. Right, so I think it's pretty easy to understand what's happening here. Chapters 1 through 4, general stuff, apply to all electrical installations. Well, once we get special equipment involved in chapter 6, or special conditions and how this equipment is installed in chapter 7, yeah, we're going to have rules in there that are going to differ. They're going to have additional requirements or some allowances that differ from chapters 1 through 4. You need to be aware of that because sometimes you may run into an AHJ that, for instance, is very familiar with chapters 1 through 4, maybe not as much with chapter 6 or chapter 7, may not realize there's something in there that allows you to do what you're doing because, hey, well, chapter 4 says you got to do it different. Right, so it's important to understand 6 and 7 can take precedence over 1 through 4. Okay, so chapter 6. PV is special equipment. Hey, the code says it. Special equipment. That's the title of chapter 6. Article 690, solar photovoltaic PV systems. We'll spend a lot of time in here. Let's take a look just quickly at the layout. I don't want to spend a ton of time on this, but you can see the article, Article 690, it's one of the articles in the chapter, is broken down into 8 parts. General requirements, definitions, general requirements. Part 2, circuit requirements, maximum voltage, arc fault protection, rapid shutdown, circuit sizing. We'll spend a lot of time on that. Disconnecting means has its own part 3. Wiring methods and materials, part 4. That's where we're going to find things that differ from wiring methods in earlier parts of the code. Grounding and bonding, the same thing. These are special requirements that apply to PV systems that are going to, in some cases, refer back to Chapter 2 and Article 250 on grounding, or they may give us different requirements or allowances. If you spent much time around PV systems, you probably realize there's a lot of labeling and marking requirements. That's Part 6. Part 7, connection to other sources. There, we kind of spend most of our time in a different chapter, Chapter 7, special conditions. We'll be spending a lot of time in Article 705. And then finally, energy storage systems, Part 8. Not going there so much because that's not really the focus of this particular class. Before we go further, let's note the requirement for qualified persons only that's laid out in the National Electrical Code in regards to solar PV systems and installing them in special conditions. So first, let's turn to Article 100. These are definitions, Article 100, and you can go through there. There's a lot of information in there. There are some definitions that are super critical to PV systems, but they live in the front of the book. They don't live in Article 690 about PV systems because, well, they're referenced in a bunch of other areas in the code book as well. So we want to have them in the front. But one example is the definition of what a PV system is. It's in Article 100, not Article 690. But I digress. Let's talk about qualified person. One who has the skills and knowledge related to the construction and operation, safety training, avoid hazards. Okay, I think you get the idea here, what a qualified person is. You know what you're doing, you understand the process, and you know what the hazards are and how to avoid them. So there's a lot in that. That's a pretty heavy term there. And, we want to realize that there is a requirement for qualified persons called out specifically, 690.4c. PV equipment and systems shall be installed only by qualified persons. 705.8. Parallel electric power production sources shall be installed only by qualified persons. And even in the energy storage article, 706.3, energy storage systems and associated equipment, you got it, qualified persons only. Okay, so now this one's a little tricky because in a lot of places, how do you become a qualified person? Well, in some areas, it's, hey, I passed a contractor's exam, I'm licensed, and I have insurance. I'm able to pull permits, I'm able to call for inspections, I'm able to sell the equipment and install it, I'm a qualified person. Other jurisdictions may have different interpretations of what it means to be a qualified person. That's a big word, interpretation. Maybe it's not a big word, but it's an important word. Because as much as we like to say, hey, here's the language, it's all subject to interpretation. And in the end, your AHJ is the one that is making that interpretation. So you need to know what qualified person means to them. It may mean something different to them than what it says on the screen and what you have in your mind. And that applies to really everything we're going to talk about. So much of this stuff is able to be interpreted slightly differently, and sometimes it's because maybe the language isn't as clear as it could or should be, and that leads to lots of discussions. We always have discussions with inspectors or building departments. We don't have arguments. Arguments, not good. Discussions, very good. They can be productive. So keep that in mind really throughout. And that's one reason, as I said earlier, it's always good to go back to that source material. Hey, I think I know what I'm talking about, and I usually know what I'm talking about, but that doesn't mean you should always take me at my word. And so as we're going through the course, if you have access to a hard copy of the National Electrical Code, or you can get online and look at it, pause the video, go to the source. Hey, you see 3 code references on the slide here, plus the definition in Article 100. Go read and see what they actually say. It'll help you get familiar with working your way through the book, and you'll see the real language, not somebody else's interpretation. What does it really say? Don't always listen to what somebody tells you it says. All right, that was a little long-winded roundup there, but next up we're going to dive into instructions in listing and continue our discussion of the NEC. Thanks.